Hi, I'm Frank Nana with TRICOR Systems. We're going to go over a quick example of a real-world reflective color measurement for the print industry. Okay, the print industry, here's a real-world example. Do these two prints match? One would be signed off by the customer, can be considered the proof or the standard or reference. And the other one is the first print coming off the line. The question is, do they match? Before I print 1,000 of these, do these match? So we're going to walk through how simple this is to make this measurement on the Model 600. So previously we've taken the standard image and we've saved it. So now all we have to do is measure any type of samples from now on to do a full frame measurement. So we place this into the system. We start the measurement using the software. It takes about 1 minute to take a measurement. During this 1 minute, I like to take the time to describe some of the components in the system. The Model 600 imaging spectrophotometer is mounted up high in the chamber. We have two DC modules. These DC modules are DC controlled, very tightly controlled output with a very specific spectral output. And the enclosure. This particular enclosure is scaled so that we can measure A-size prints, and it's black in color. It's black because we want to control all secondary reflections, and we also have a chamber because we want to control the exterior and the environment lighting from polluting our measurements. So those are the different components. The table, you can purchase a optional vacuum table, and there are many other options for the chamber. Okay, the measurement is complete over here. Let's take a look at full frame delta. Okay, we're clicked on the full frame color difference capability. The color images of the sample is being created, and now we see it in front of us. So right here, this image right here represents the the standard image. And this represents the standard image that the sample image that we just measured. Okay? So the first thing we do before we can do a full frame comparison, we must align the two images. So there's an automatic algorithm in here that aligns the sample image to the standard image. Now you may or may not on this video be able to see that it did move and rotate. So now these two images are now perfectly in line. I'm going to press the calculate button. So what's happening during this process is 1.2 million color differences are being calculated. One for every pixel location, and the complete mapping is now shown over here in the lower right corner. Any pixels in this image color-coded green represent a delta E of less than 2.5. Anything in yellow is less than 5.0, and anything red is less than 10. Now those three ranges are user programmable. That happens to be the values that I've currently set them at. Okay, we also have cursor capability. You could come in here and look at colors of individual areas within the image itself. But the big powerful capability here is this full frame mapping. So that full frame mapping can now be printed out in color for historical purposes. So you could generate a full frame difference, generate the mapping, hard copy mapping, which you could use for records, historical purposes, quality control, full frame. 100% of the area has been calculated for delta E. Very powerful system. You saw how easy it was to to generate this delta E mapping. We're extremely excited